Hello everyone, today is the 11th day of Leetcode 75 challenge. Let's begin with the 11th question. Question number 392 is subsequence. Level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. So you have been given two strings S and T. You need to check if S is a subsequence of T. Okay, let A, B, C, D, E, F, G be a string which is equals to T. And S is a subsequence, let it be A, C, B. Okay. The subsequence means what? You can delete some or no characters from T. From this, you can delete the characters or not, right? The remaining characters in T should appear in same order as they appear in S. So the order of A, B, C, D, E, F, G, H should be if we remove F also, G also, and C also, right? The leftover values which we have here, which is A, B, E, F, the order related is remaining, right? The order has not been changed. So it should be same in the subsequence string. Like if you see here, we have A, B, C, D, E, F, right? And in subsequence, what we have? We have A, C, and D. After removing B, E, and F, we have A, C, D, and it follows the sequence and retains the sequence from the original string. So this is a subsequence. A subsequence is basically a substring, I could say, a substring or a piece of string consisting of characters present in the original string with the same relative order. If you take one more example here, ACE is subsequence of A B C D E. Why? A is here, C is here, and EE is here. It appears in order, right? But AEC not because A is there, fine. C is there, fine. But E is after C, right? But in this case, we have E before C. So because E comes after C in S, it is not a subsequence. Now we have to return a subsequence S of it, otherwise it as true or false. Okay, so this is what we have to check. We have to check whether S is a subsequence of T and return true or false. Constraints is length of the subsequence S could be 0 to 100 and T could be 0 to 20 power 4, and S and T only consist of lower English characters. I hope you understood the problem. Now let's move to the next slide. Let's understand the input output of the problem. Let's understand this first. We given ABC and AHB ABC. Okay, AB. Sorry, A H B G B C. Output is true. Why? From substring we have A. I will keep it here. Then we have B. We will place it here. Then C. Yes, you can see that we have the relative order maintained in the substring S, even though if we have cut down some of the values, right? So it is true. Okay. Now A H B, G, B, and C are given as A is here, C is here. We don't have X anywhere in the given original string. So output is false. Here we don't have X, right? That's why it is false. But what happens if we take another example? What you can take? We could take A, G, B, right? This will also turn out to be false. Why? We have A here, great. Where is B? B is here, G is here. From that, we can say that it is not maintaining the relative order from the original string. So it is not a subsequence. I hope you understood the input and output explanation. Now let's go to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Now imagine you are following a treasure map. Mhm. And you are on a treasure hunt and you want to have a map which could be S that shows that exact sequence of landmarks you need to find in order. The problem is that the actual path, which is T, we are walking, is a long and messy one with extra landmarks and distractions along the way. Okay. Now let's take T as the original string given and S be the subsequence, and we have to follow S to get to the point, and we have to use a path T for it. Now what we gonna do? What comes out to our what is our intuitive thought says to us? We start walking along the path T because we have to find S, right? That's why by checking each landmark. Now, when we spot a landmark that matches the next on your map as S, right? Is a landmark which you are standing in T matches with the S. You move to the next landmark on the map, right? This means we got one landmark. Now we move to the next. We mark it as something like true in our treasure map and we move ahead, right? Now, if the landmark does not match, we just keep walking in the T, which is the original path. Because to get S, we have to iterate T, right? That is the simple logic and understanding could happen, right? So if you manage to match all the landmarks in similar way, if after walking a few miles we get another string, another character in the original path T, which matches the S, we'd also mark it as something and true and move ahead, right? And if at the end we completed or we have figured out all the S values in S, then it is true, right? From the given original path T, we were able to find S in the same relative order asked. But if you don't, if some elements remains in S which does not match with the T, then return false. Simple as that. So from here we could understand that the path is one. Taking a real example is that path is one, right? And this is the S which we have to follow. Let's take this as an example, right? If this S matches here somewhere, I don't know, it matches from this distance to this distance, right? It will be true, right? If it does not, then false. When we are walking in a path, we cannot go back, right? We cannot jump. We just have to walk. So keeping this in intuition in mind, that we have to follow the T path and we have to check for S whether it exists or not in the map until unless we complete our T path till the end. Okay. I hope you understood the intuition here. Now let's move to the next slide. Now since we got the intuition of the problem, let's look into the approach, how we're gonna solve it. Now in our previous problem number 10, we understood what is two pointer, right? What is the concept of two pointer? And when we used in our previous question number 10, the concept of two pointer and find moving all the zeros to the end and moving all the non-zeros element in the front, keeping the relative order. This question is also the same. Here also we need two pointers, right? One for tracking T and other for tracking S, right? And also we have to keep the relative order in mind, right? So having the concept and understanding of two pointers on the video number 10, we can follow up here. Okay. First thing, we define two pointers. Fine. Now we have to handle the edge cases here. What to do the edge cases? For example, we have a T string, but we are not given S. S is empty. What it be? It will be false or true? It will be true because a subsequence can be 0 to the n. N is the length of the T. Okay. But so it will be true. But if S, we have some values in S, but T is 0, it will return false because to be a subsequence, we need our original string here. So these are the two edge cases we have to keep in mind while solving this problem. Now we start a loop to compare each characters. Okay, it's simple as that. Like let us take here my name as hers, fine, and we have to find h s h. This is the original path from the tuition, and this is the path we have to actually follow. Okay, we will keep t here and s here. I think j. This is I, right? I is for t and j is for s. We have to keep checking characters until I reaches the end of t. Okay, until unless the original path is completed, we have to iterate the original string. This is also understandable. And we have to go through each and every character of the t using the pointer I. So we understood that we have to have the understanding of the two pointers concept. We have to keep the relative order of the subsequence. We have to check whether the string consists in the original string or not. We have to handle the test cases. If the substring is 0, length is 0, it is true. If the original string is itself 0, then false. Then we have to iterate the complete path or the original string, and we have to look for every characters in it. Now let's move to the step 4. We have to match characters. Matching of characters of T of I matches with character of S of J. In this value hertz, this is the T and S. Let it be A S H. Okay. 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 Now I is here and J is here. If I and J matches, but here it is not matching, right? What our mind says, if it does not match, no worries. We have to move P. I would say, because we cannot move J here from here, because this is the character we have to check in the previous string. Until and unless we don't find this A in the original string, we cannot move this. Right? We have to move then I in the from the original string itself. Now here we can see that both the character matches. Now we have the understanding that A is in original string also and in the subsequence S string also. Okay, now we will move both because we don't need them anymore. We are sure that this value we have it there. Again, these are not similar, right? But we cannot move S J from the string S. So we will be moving I in the T. It will come here. Again, this matches. Now we will move both here, and again this matches. So we got the subsequence is equal to the original string with the relative order. Okay, so this is what is explained in step 4. Move both pointers if they are equal. This means correct character is matched. So we check the next character. A character is not does not match. Just move the I pointer. This means you're skipping the unmatched characters in T by looking for next potential match. Okay. Now at the end, we have completed our iteration. Now what? Now what was the size of? We need to check whether we iterated a complete S or not, right? So for that we will store size of it. Okay. And we know that indexes are zero based. So if the size is 3 here, it will be 0, 1, 2, right? And when J is in this case and their values matches like H and H matches, so J will go for again, right? J will become plus plus again. And I also will become plus plus again, right? Then only the condition will get false of I less than N, J less than size, right? Then we will come out of the loop. Now, J is equals to 3 in this case. And the value of N is also 3. Okay, let me write it here. Now, J is equals to 3 and N is also equals to 3, right? And I mean to say size for the subsequent string. It will be J. Okay. So if J is equals to, which is a transitive property, if J is equals to S Z, it means we have iterated the subsequence S, right? All characters in S were matched in correct order, so we will return true in that case. But if J is not equals to S Z, which will be basically less than this, then we will return false, which means that we have not completely iterated the string S or subsequence S. So I hope you understood the approach, how we are using the two pointer concept here and how we are iterating I and J and how we are comparing the values and why we are comparing J with size of the subsequence here. Now let's move to the next slide. The code is exact copy of the approach discussed. Okay, let's understand it by line by line. We will keep I and J equals to 0. Okay, N is the length of the T and SZ is the length of the S. Now, this is the edge cases I talked about. If subsequence is 0, length of subsequence is 0, return true because subsequence can be from 0 to n length. But if the original string is itself 0, it will return false because it's not possible to compare them, right? If we have subsequence of some value n and we don't have the original string, then it does not make sense to compare them, so it will become false. Because without an original string, there could not exist a subsequence. Okay. Now, while I is less than n, we're keeping the iteration of p as main here because this will be the termination condition. Now, while I is less than n and j is less than sz, and if they're equal, we will iterate both, increment both. Otherwise, we will just increment I value, which is the original string index. Now at the end, we're checking if j is equals to the size or not. If it is written true, which means that subsequence has been iterated completely. Otherwise, we return false. Now the complexity comes out to be O of n, the time complexity, because we're iterating n times, which is the size of the longest string or t. And space complexity is O of 1 because we are not using any data structures to store the values. We are just returning true and false in this case. I hope you understood the code and time complexity. Now let's move to the next problem. Now let's move to the next slide. Now let's understand the problem with a dry run. Okay, A, H, B, G, D, C. Okay, this is T. S is equals to A, B, and C. Okay, according to our code, I is here, J is here, and if both are equal, we increment J also and we increment I also. Okay, okay. Now I is an index. Let me mark index also 0, 1, 2, 3, 4, 5, right? And this is 0, 1, and 2, right? T is of length 6, S is of length 3, right? Now we can say H and B are not equal, so move I again. Now we can I is in this second index, B and I are T of I matches with S of J, BB, right? So we will increment both I and J together. Now J is at C or the last index of subsequence and I is here in G. They are not equal, we will increment I again to D. They are not equal, we will increment I to C. Now look, both are equal, right? Yes. So we increment both. So J becomes 3, I becomes 6. Now I is not less than, now while I is less than, the condition was while I is less than N. N was 6. But now is I equals to 6 and J was also said to be less than equal to S of J. S of J value was 3 and now J value is also 3. So they are equal, right? So the condition falls out and loop ends. Now at the end, the condition was if S of J equals to S of, if J equals to S of SZ or SZ equals to SZ, right? Which is true in this case because J is 3 and SZ is also 3. So we return true here. Hmm. And this is how the code works in the dry run is. If we take a condition here that we are putting instead of C, it will be F, right? Let the J be here in this case with index 2, right? And the iteration gets completed. Okay. Now the J value remains 2, but it is not equals to S of J, SZ. So we return false. Okay. I hope you understood the dry run and the conditions while we are taking it. Now let's move to the next slide. Now since we are familiar with the problem and solution, let's move to the lead code and code the solution. Okay, we have to initialize I equals to J, which is 0. Both should be 0. Let's take the length of T. SZ will be the length of subsequence. If SZ is equals to 0, what will be the output? For true, right? But if N itself is 0, output will be false. Now while I is less than N and if I is less than N and J is also less than SZ and T of I equals to S of J, we just increment I and J, else we just increment I, right? And if J becomes equals to SZ, we return true, else or we can just return false. Let's run the problem. We passed the test cases. Now let's submit the solution. Our solution got accepted. Code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.